Hello. Am I visible and audible? Please confirm. Please confirm. Yes. Hi. How are you all? How are you doing? Hi Satya. How are you? Fine. Okay. So shall we start with our discussion for today? Shall we start with our discussion? See, to do a video about GD, we don't have all the details yet here. We are still waiting for the details. So yeah, we will start with our current topic. The topic that we are going to talk for today is about space technology. Right? The class that we have today is about space technology. There are a lot of questions that were there that were seen in space technology from steno paper, and when we were discussing about the predicted topics, the important topics from where questions can be asked in the upcoming exams, on 6th of August we came up with this list. And there I told you there can be questions on ISRO, there can be questions on PSLV, GSLV, etc., NISAR, ISS, Axiom 4 mission, etc. And honestly, all these questions were asked in steno exams. So, the topic for today that we are going to talk is all about space technology. And in space technology, this is your index. These are the topics that we are going to study in these two classes. We have two classes on space technology. Today is first class of space technology, and the next class will be day after tomorrow. Tomorrow we will do one class on economy important topics and the monetary policy, money and banking. Day after tomorrow is a second class for space technology. As a part of these two classes, we have to study basics of space technology, engines, launch vehicles, famous space missions of the world as well as ISRO. Then there are observatories. Observatories are places from where we look at the stars, we look at the sky, and we look at our constellation and we try to understand how things are moving, what are the relative positions of one with respect to the other. All those things we do from observatories, and those are there, and such places are called as astronomical observatories. So this is our index of the class. And when you are studying about ISRO, you need to study standard missions, most famous missions, very great achievements of ISRO. Then you have to look at certain initiatives where ISRO is taking up various activities. As a part of those activities, they are just like schemes on our day-to-day life. So as a part of these activities, what ISRO does is ISRO comes up with scholarship tests. ISRO comes up with various science-based programs. The aim is to ensure that the awareness about space science increases across everywhere. So we have to study about them. Then ISRO is doing a lot of joint collaboration activities. As in, ISRO is working with, for example, France, Japan's JAXA, STARC countries. So ISRO works with various different organizations. We have to study about ISRO's joint collaborations and also missions of ISRO in the last 2 years. So this is our index for today, and we will be starting with solar system. Can someone tell me what is or how solar system is formed? How solar system is formed and what is our galaxy? I'm waiting for your answers. What is our galaxy? Milky Way galaxy. And how did our solar system form in the first place? All right. So basically, the entire solar system formed in a specific manner, right? You're all absolutely right. Through Big Bang Theory, Big Bang Theory explains everything. And originally, our entire solar system is a mixture of dust, gases, etc. All these dust, gases, etc. were revolving around each other with a great amount of pace, and these particles were held together using gravity. The dust, all the particles were held with the help of gravity, and as they started rotating around and around, as they started rotating, the larger particles started getting accumulated together and the density continued to increase. So, density increased and the weight of this entire system increased, and after a point of time, it collapsed. That is, it broke down because of the heavy weight. Now when all these particles are rotating so much, obviously because of rotation there is a frictional force. When there is frictional force and rotation, don't you think temperature will rise? Yes or no? Temperatures will rise when there is a lot of friction. Yes. Yes. So when the temperature increases, then obviously heat begins, and eventually what happened is it got ignited. The dust composition, whatever hydrogen, helium, and all the other elements are there, because of the heat, because of the increased friction, they got ignited, and this led to the formation of sun. So sun is the first body that was formed. After sun's formation, the entire gases and dust started forming as a cloud. For example, this is the sun. Okay, just a second. For example, this is a sun at the center. This is one small cloud particle. This is one small cloud particle. This is one small interstellar cloud. Cloud is nothing but a mixture of dust, gases, ice, etc., etc. So there is sun at the center, and this is one bunch of gases and cloud. This is one bunch. This is one bunch. So in this manner, there was a lot of cloud that formed, and these materials started spinning together. The spin increased and increased. Slowly, it formed a flat disk. So, initially, there was a lot of gas. The weight increased because of the frictional forces. It got burnt and it got ignited. From ignition, there is sun. Around the sun, there are a lot of bodies that formed around. They started rotating and they formed a disk called as nebula. Now, after a nebula is formed, slowly small particles started. No, there was merger of small particles, and individual planets were formed. And around the sun, lot of celestial bodies got created. So, is this clear how our basic universe is formed? Initially, there was a lot of dust and gas. It revolved and revolved. Yes, centripetal forces, etc. So it revolved because of the friction. First is sun. After sun, there are a lot of bodies. These small celestial bodies got created, and basically, our entire universe is created in this format. Now, if there is one thing that you notice in this entire universe, what is a common thing that is there? Isn't it movement? Yes, centripetal force, you're right. Isn't the movement common in the entire process? The formation of galaxies, formation of universe, formation of sun, etc., etc., everything is all because of movement. No, there is no atmospheric pressure, etc., etc. Yes. So, entire thing is because of movement. And there is a path along which the bodies will move. For instance, this is your sun. For instance, this is my sun, and the body is revolving around the sun in a particular path. Let's say this is second body. It might rotate like this from north to south. This is rotating like this. There is something else which is rotating like this. So, any body will rotate in a particular path. The path along which any body is rotating is called as orbit. Orbit is the basic word that we have to study in space science. Various bodies, various satellites are launched into different orbits. So the first thing that we need to understand is all about orbits, and orbit is a curved path in around which the bodies will continue to revolve. Now, as the bodies are rotating around each other, let's say there is one bigger body and there is one smaller body. Bodies are rotating or revolving around each other. There is an experience of gravity. Gravity is the force of attraction between any two bodies, and gravity is directly proportional to the masses. We studied about this when we were in our schools. G is equal to m1 m2 by r square. We know this. So gravity is the force of attraction. Whenever there are two bodies that are rotating, that are revolving around the universe, there is lot of attraction for the between these two bodies, and because of the attraction, they start going around in a particular path. So the path around which these are rotating, such path is called as orbit. Orbit is the first thing. Now we will look at various kinds of orbits and the words that are associated with orbits. Then we will come back and understand how satellites rotate. Right? So basically, orbit is a path around a celestial body. Now, when we are considering about Earth's surface, we have Earth at the center. There is atmosphere on. Just give me 1 second. Just give me a moment. I will get one round body or something to demonstrate this in a better manner. Just give me 1 second. Sorry for the delay. Is my audio and video clear? Is my audio and video clear? Yes? Okay. For the next 15 to 20 minutes, let us utilize this egg as our example, and we will consider this egg as our Earth surface. Okay. This is our Earth for this moment. Now, when I'm launching any satellite, when I'm launching a satellite, Earth has an atmosphere around it. Satellite has to cross this and it has to get into space, and satellite will observe Earth from a position like this. This my pen pointer is my satellite, and it will start observing my Earth position like this, right? So for my satellite to start from the Earth surface, basically it starts in the Earth surface, it travels up and it tilts. This is the position it takes, and it starts rotating and it will start observing the Earth. Now my satellite has to start from the Earth surface, and it has to cross the Earth atmosphere, and it has to get into space and turn into the position. Now in physics there is a velocity called as escape velocity. The meaning of escape velocity is the velocity that is needed, the push that is needed to throw any body out of the influence of Earth gravity. For example, this is, as I was telling, this is my Earth surface, and from Earth, let us assume till this particular height, you have the influence of gravity. As long as any body is within this pen's range, this will influence gravity. And once you escape out of this position, then you don't have any gravity. This velocity, the velocity that is needed, the push that is needed to throw any body out of the Earth's gravitational influence, that velocity is called as escape velocity. Now, let me tell you, satellites are not launched at escape velocity. That is, satellites are always under the influence of Earth gravity. Satellites are in the influence of Earth gravity, but the velocity is slightly less than escape velocity. So, the velocity that is needed to push any satellite into the atmosphere, such velocity is called as orbital velocity. So, what happens is, usually, let us assume for a moment this is the surface of the Earth and this is my rocket. This is a rocket, and on the top of it I have a payload. Now what happens is, when a satellite is launched, at each stage I have engines. At each stage I have fuel, I have engines. And once this is fired and the rocket launches, at each stage one particular motor, one particular engine will be lost, and it keeps going outside and outside. After a particular point, what happens is, at the top position, at this particular top position, I will give enough force in such a way that the rocket that is going like this turns into a 90-degree tilt. This, the position where I am giving this push, this is a final propulsion. So at this point, I will give a push and my satellite turns like this, and the satellite will continue to rotate, and this velocity is slightly less than escape velocity. That is, my satellite is not completely out of Earth atmosphere, but it is way away from Earth's surface in such a way that the influence of gravity is still very less. The amount of air, the amount of dust and gases that are there are very, very minimal. So at this particular point, there is very less friction, there is very less force. So the satellite continues to revolve around the Earth's surface, and that is how basically orbits and satellites work. So did you understand what I spoke till now? Did you understand what I spoke till now? The vehicles that carry, yes, so the vehicles that carry our satellites, they are called as launch vehicles. Launch vehicles have various motors at different stages. You have motors, you have thrusters, you have boosters, right? So you have all of them, and at each stage you have different thrusters and boosters. And as our launch vehicle takes off, at each stage one module is left off and the fuel is burnt out. So these are called as launch vehicles. And once we push our satellite out of the Earth's surface, what happens is, it reaches a particular height, it goes with the orbital velocity, there it gives a push. Once a push is obtained, the satellite becomes self sustaining in nature, and it continues to maintain the same amount of velocity. right? So this is the basic functioning of how a satellite works. So you have solid motors in the first stage, then you have another motor in the second stage, finally you have a payload. This is called as payload attached or the final propulsion, and this propulsion is the final boost. Array, I'm so sorry, yeah, I'll repeat, no issues, I will repeat. The vehicles that we use to carry, yes, I'm extremely sorry, yeah, the vehicles that we use to carry are called as launch vehicles. We have various kinds of launch vehicles. And at each stage of launch vehicle there is a particular jet or there is a particular fuel. See, 90-degree rotation is needed because, again, I'll come back to the same point. Let me complete this. I'll answer your question why 90 degrees is needed. Yeah, that's a very good question. Basic difference between a PSLV and GSLV is that PSLV has a limited payload capacity. Once I tell you what are orbits, there I will tell you these are called as sun synchronous orbits. These are called as geosynchronous orbits. So basically, PSLV is a vehicle that is used to put satellites into low Earth orbits. The 90-degree rotation is because, as I told you, this is my surface of the Earth. Okay, this is my surface of the Earth, and this is the direction in which I'm firing my satellite rocket. Satellite is traveling like this. Now, if I put my satellite in this manner at this point, it can't rotate, right? The path around the Earth is circular. So I'm firing like this. Only when I give a 90-degree push, it can rotate around the Earth's surface. So for this purpose, you need a 90-degree rotation. Now, you have PSLVs and GSLVs. I'll tell you the difference between them. And as I was telling you, these are various stages. In the first stage, you have solid rocket motors, and in the second stage, you have other kinds of motors. You have a propulsion that is attached to the spacecraft. This propulsion will give the 90-degree necessary shift that is needed to ensure that the satellite, the actual payload, is revolving around the Earth's surface. These are the basics of the orbits. Now, there are different kinds of orbits around the Earth. The types of orbits are decided based on the height at which they are there from the Earth atmosphere. So, for example, again, this is our Earth surface, and this is the entire height. Okay, at the first point, at this particular point, till this particular height, we call them as low Earth orbits, and till this height, we call them as medium Earth orbits, and at this point, we call them as high Earth orbits. The basic categorization of orbits is dependent upon the height from the Earth's surface. And as we know, there are three types of orbits: low Earth orbits, middle Earth orbits, and high Earth orbits. Of these three, most commonly used orbits are low Earth orbits and high Earth orbits. Within low Earth orbits, there are various types of orbits called as polar orbits, sun synchronous orbits, etc. etc. I will tell everything with the help of an example again. Now tell me, I want you to answer a particular question. This is my Earth surface, and there is a satellite at this particular height. Height, let us call A. A is one height and B is one height. There is a height A, there is a height B. There is a satellite at height position A, there is a satellite at position B. Which satellite do you think is more efficient to monitor the surface of the Earth, A or B? Which is more efficient, which is more convenient, A or B? This is position A and this is position B. A is closer to the surface of the Earth, B is farther to the surface of the Earth. A or B? There are mixed answers, A and B. Now I'll give you one specific example. There are two satellites. One satellite, I want wider coverage. The other satellite, I want precise coverage. Satellite 1 is for, let us say, military purposes or Earth observation. I want it to be very, very pinpointed and precise. Where will you place it, A or B? Yes, A's range, you are absolutely right, Akash. So A's range is very small. No. A's range is very small, but it is very accurate. So at a point A, we will place those kind of satellites which need to observe the Earth. Right? So we will have observatory satellites at low Earth orbits, right? And at a particular distance, at a far off distance, we will place satellites which are usually used for communications. For communication purposes, etc., we place them at position B. So position A, we call them as low Earth orbits, low Earth satellites. Position B, we call them as higher Earth orbits or geo Earth orbits. Now, there are various kinds of orbits. First orbit, the orbit that is exactly there around the equator. The advantage of the satellite that is placed exactly around the equator is very simple. If this satellite is absolutely above the equator, then the speed with which the earth is rotating will be same as the satellite's speed, which means satellite can constantly focus on a particular location, on a fixed location. So if you want your satellite to be on a fixed location, you need to place it on an orbit which is exactly above the equator, which coincides exactly with the equator. If you don't need such a purpose, then you can ensure that your satellite is rotating in this manner from north to south. So if your satellite is rotating in an orbit which is from north to south, you call them as polar orbits. If the satellite is exactly placed above the earth's surface and the satellite's speed is as it is exactly as the earth's speed, such orbit is called as geostationary orbits. So with the help of your slides and images, I will help you understand various kinds of orbits, but I want you to know the height. The orbits are decided based on the height at which they are placed. Now, as I was telling you, we have low earth, middle earth orbits, geostationary, geosynchronous, and polar orbits. These are various types of orbits. Now, the first type of orbit that we are talking are low Earth orbits. Now, as I was telling you, low Earth orbits, their satellites are to be faster. But if you want your satellite to be closer to the Earth's surface, then you need to place them in low Earth orbits. For example, we have something called as International Space Station. International Space Station is basically something like an office, a research and development office, where astronauts go, sit and conduct experiments. For our understanding, for this moment, we will call International Space Station as a R&D space object. So there, people have to go, stay, work and come back. For that purposes, we need such things to be closer to the Earth's surface. So International Space Station is placed in a low Earth orbit, and if your object is in a low Earth orbit, then it is extremely faster. For example, International Space Station completes rotation around the Earth in approximately 90 minutes. So in a day, an International Space Station can complete rotation around the Earth's surface for around 15 to 16 times. So such orbits are called as low Earth orbits. Low Earth orbits are very good if you want imagery, if you want to take pictures, if you want to do military grade pictures, if you want spying, then low Earth orbits are absolutely perfect. For example, you might have seen various images that were published after Operation Sindoor, the photographs from the Murid K or Bahawalpur, Noor Khan base, Kirana Hills, etc. So where did we get that intelligence from? It is all from those satellites which are placed in the low Earth orbits. From low Earth orbits, we can get very good high quality images. So low Earth orbits are for imaging, and one famous body that is there on at low Earth orbit is International Space Station. Now there is one thing called as Van Allen belt. Van Allen belt is very interesting phenomena that happens around the Earth's surface. We all know that there are a lot of charged particles around the Earth's surface. There are a lot of charged particles in our Earth atmosphere. There are a lot of charged particles in Sun's atmosphere also. These charged particles interact, and around the Earth's surface, there are certain zones where there are heavily charged particles. For example, this is our Earth surface here. Let me change the color. Yeah, this is our Earth surface here, and this is one belt where you have heavily charged particles. Around the Earth surface, we have certain places where we have very heavily charged particles, and such belts are called as Van Allen belts. The belts where, just a second. Yeah, the belts where there are a lot of charged particles that are there around the Earth's surface. Such belts are called as Van Allen belts, and they can ask you this question directly. The reason why I said Van Allen belt is Van Allen belts are the belts of radiation that are there around the Earth's surface. So when you are placing any satellite in the low Earth orbits, you need to place them below 180 kilometers. So if this is Earth's surface, you have to place it below 180 kilometers, and after 180 kilometers you have Van Allen belts, and beyond Van Allen belts you can place your satellites again. So this is about the low Earth orbits, and there are different kinds of satellites that are there in low Earth orbit. For example, all the Earth observation satellites. There are Cartosat series. I'll talk about these satellites, don't worry. Cartosat series. Then you have InSat, you have ResourceSat. All these are satellites that are observing the Earth's surface. So such orbits, such satellites are placed in low Earth orbits. Do you have any questions till now? See, with respect to taking notes, Ganesh, this notes is enough. As in, these slides are enough. You can revise from these slides. You don't have to worry about notes again in specific. You can use these slides for your revision. Okay. And you can just, once the class is completed, you can go through the slides. You will understand what points are relevant, and you can simply make a small revision notes. That is enough. So do you have any questions till here? We spoke about what are orbits. I told you where is International Space Station. We saw what are low Earth orbits, and we also discussed about what is a Van Allen belt. So is this clear? Can someone tell me what is a Van Allen belt again? What is a Van Allen belt? Okay, I'll slow down. Done, noted. I will slow it down. Okay. Yeah, wonderful. Van Allen belt is a very highly charged belt. Now, can I proceed further? Charged particles around the Earth's surface are called as Van Allen belt. Oh, nice. Absolutely nice. Yes. In the atmosphere. In the atmosphere, yes. Now, next type of orbit that I'm going to talk to you is about polar orbit. See, this is Earth, as I was telling you. This is Earth. And if the satellite is rotating from pole to pole, okay, this is North Pole, North Pole, this is South Pole. So the space around the Earth's surface where the satellite is rotating from pole to pole. It starts from the North Pole, it comes to South, North, South, again. It is rotating in this manner. These kind of orbits are called as polar orbits. Polar orbits are precise from pole to pole, and these are low Earth orbits. As in, the height is less than 180 kilometers. So you have Earth's surface, there is 180 kilometers. Below 180 kilometers, the satellite rotates from north to south. Earlier, I spoke about the satellites that were rotating from west to east. Now, in polar orbit, the satellite rotates from north to south. So, those kind of orbits are called as polar orbits. Next type of orbit that is very interesting is sun synchronous orbits. As the word says, sun synchronous orbits meaning is the position of the satellite is in synchronous with the position of the sun. For example, I am sitting in Hyderabad, and in Hyderabad at around 2 p.m. Okay, just as notification. Okay, I'm sitting in the city of Hyderabad, and at around 2 p.m. sun is at a particular location in a particular direction. The meaning of sun synchronous orbit is at 2 p.m. sun is at a particular location, my satellite will also be at that particular location. So the satellite is in synchronous with the sun. At 5 a.m. or 5 p.m. sun is at a particular location along this line, the satellite is there. At 6 a.m. satellite is there. So satellite's rotation, satellite movement is in synchronous with our day and night. And we use these orbits for those kind of satellites where daylight is extremely important. If daylight is enough and you don't want it to work you don't want it to work much in the darkness, and daylight is more than enough, for such satellites we use sun synchronous orbit. Sun synchronous orbits are orbits where the satellites are in sync with the sun and their position is always same with respect to the sun. So such orbits are called as sun synchronous orbits. So in sun synchronous orbits, we usually place those kind of satellites where you want to map forests. See, for example, you are preparing a survey. Your survey is your survey's aim is that you want to measure the amount of forests. Do you want your satellite to work at night? Is it really necessary that you map your forest at night? Can you really map? Can you map the green cover at night? No, right? So if you want to monitor the land, you want to map forest, you want to check green cover, you want to see how urban growth is happening, where cities are coming up, what is the traffic congestion. If you are aware, Bangalore traffic police also use satellite data to monitor to improve their traffic management. So if you want to use satellites for all those kinds of purposes, for agriculture, to track wildfire, to track earthquakes, these kind of activities, we use sun synchronous orbit so that daytime is enough. We get good amount of images during in daytime, and that should work. So these are about the sun synchronous orbits. The examples are, for example, there is a Landsat. Landsat is a satellite of NASA. Then we have IRS. IRS is India's remote sensing satellites. They belong to India. Then you have Sentinel. Sentinel is European Space Agency's program. So these are various orbits where these are various satellites which are present in sun synchronous orbits. So Earth observation satellites, remote sensing, Earth observation satellites, remote sensing satellites, or for example oceanography. You want to study ocean mapping. Whatever you want to do during daytime, you usually place them along a sun synchronous orbit. Is this clear, or do you have any questions on sun synchronous orbits? Do you have any questions on sun synchronous orbits here? Cool. Are we good to go to the next one? IRNSS is using geosynchronous geostationary orbits. We will come there. IRNSS is placed way above. It is placed at a height of around 35,786 kilometers from the Earth's surface. Yes, Leo moves from west to east. Yes. So IRNSS is using geosynchronous geostationary. It is using a mix of those two. So IRNSS is at a very, very large distance. Now, of all the orbits, there is one orbit that is always very high in demand. Every country wants to put their satellites in that orbit. Such orbits are called as geostationary orbits. This orbit is extremely crowded. Want me to give? I'll talk about it. We will talk space current affairs in the second class. Okay, TNT. We will talk about space current affairs in the second class. Today I'm giving you theory. The second class is all about application current affairs, etc. etc. So there is one orbit around the Earth's surface which is always crowded. There is a lot of demand for it. Every country wants to put their satellites there. The reason is, if you put your satellite at that particular position, the position is exactly in synchronous with the equator, and you can constantly focus on a point. For example, this is the Earth's surface, and I am putting my satellite here at this point. My satellite remains here, and I can have a 24 cross 7 observation. 24 cross 7, my point is constantly focused on there. If the Earth is rotating, my satellite also rotates exactly. Such orbit is called as geostationary orbit. Any such orbit, you call it as geostationary orbit. Geostationary orbits, it is at a fixed altitude. It is at a height of 35,786 kilometers. So at a height of 35,786 kilometers, precisely above equator, we have an orbit called as geostationary orbit. If I am placing a satellite on geostationary orbit, it maintains a fixed position. No, the satellite will continue. We can alter the course, and the satellite will change. The position of satellite will change along with the Earth's surface, and it is there. So such orbits are called as geostationary orbits. Geostationary orbits are very, very high in demand. Usually we have our navigation systems, telecommunication systems are generally placed in geostationary orbit. The reason is very simple. Here on the Earth's surface, I have an antenna placed. Antenna is let's say looking at at a particular location, or antenna is fixed at a particular angle. Now, if unless my satellite is fixed, my antenna and satellite are communicating. Earth is rotating, satellite is also rotating. The communication is consistent. You will not have any interruptions as long as you're watching your TV. So, for communication, for telecommunication, for all these purposes, we use geostationary orbit. right? Is this clear? Geostationary orbits exactly at an altitude of 35,786 kilometers. The speed is 3 kilometers per second and the direction is west to east. Hi, Soumya. So these are fixed. The position is fixed, direction is fixed, speed is fixed, height is fixed. Now, don't you think it is very difficult for us to put n number of satellites constantly there? Sir, about navigational radars or satellites. Okay, I'll talk about it. Now tell me, don't you think we can't put all these satellites at the same orbit? It will be very crowded and it might cause a lot of space debris. It becomes very difficult for us to handle it. So there has to be an alternative. So the alternative is geosynchronous orbit. The other alternative is geosynchronous orbit. The only difference between a geostationary orbit and a geosynchronous orbit is geostationary orbit, it is fixed, it is around the equator. Whereas geosynchronous orbit is something like a sun synchronous orbit. Geosynchronous orbit is not around the equator, it can be in any direction, but the position is always in synchronous with the sun. It is slower, it is constant, but the position is along with the sun. So if I have a satellite, I want it to work day and night 24 cross 7 from the same position, then I will put it in a geostationary orbit. Whereas if I have a satellite which has to work at the same position but daylight is enough, then I will utilize geosynchronous orbit. So satellite is at the same position in the sky after a day, so it is in synchronous with the sun. Now tell me, where do we put our GPS system? Geostationary or geosynchronous? Where should we put them? Where do we put our GPS kind of satellites? It could be IRNSS, it could be GPS, it could be GLONASS, whatever it is. Where should we put our GPS satellites? Yes, so GPS satellites uses geosynchronous because you don't need light. Yes, geosynchronous are used for GPS satellites, but India's IRNSS uses a mix of geostationary and geosynchronous. Okay, you want me to repeat the differences? It is very simple. Let us assume this is my Earth surface. I am talking about two orbits. Both the orbits are at a distance of 35,786 kilometers only. One orbit it is rotating exactly from west to east. One orbit it is rotating exactly from west to east. Whereas the other orbit there is no fixed position. Right? If there is no fixed position, I'm calling it as geosynchronous. Otherwise, I'm calling it as geostationary. So these are various kind of satellites. In geosynchronous, you have broadcasting applications. Mainly, you have navigation satellites. You have communication satellites. Usually, they are placed in geostationary orbits only. So, as someone was asking, what is the difference? The difference is very, very simple. In a geostationary, satellite is at a fixed position, whereas in a geosynchronous, the satellite returns to the same position. That is, the rotation of satellite is in synchronous with the rotation of the sun. So, this is about the satellites. This is about the orbits and the positions. And yeah, don't worry about it. Yeah, we will talk. I am working out on a video tomorrow. We will talk about how we have to handle these kind of situations, mostly day after tomorrow. Let's take a small break for 1 minute. We studied for 35 minutes. And there is one thing that I want to talk to you all just for 2 minutes and we'll come back to studies. It's okay. See, the situation is very bad outside. There is a lot of chaos. There is a lot of things that are happening which is affecting our mental state. Before I talk about it, tell me, how are you affected because of all of this? What is going on your minds? For 2 minutes, we will talk and we'll come back to studies again. No issues. So tell me, how is your state of mind at this point of time? Because that is more important. Cutoff could be somewhere at 130s, dear. It will be somewhere at 130s. So yeah, what is going on your mind right now at this point? You're all disturbed. You don't feel like studying at all due to controversy of teachers. There are okay. I will tell you one statement. I will pass one statement. Okay. Worried and sick. And may continue with SSC career. Okay. Okay, before I address all your questions, I want to pass a statement. I might sound very controversial, but I will speak fact. That is, first thing, whoever you are considering as a teachers, including me, we are not teachers, you are not students. We are tutors, you are aspirants. You have a goal, you want to achieve a better position in life. Your studies are completed, you are graduated, you are not students, you are not teachers. This is not a gurukul kind of a setup, and nobody needs to be worshipped, nobody needs to be idolized. Any tutor can do 10% of the job at best. Rest 90% has to be done by you. I want to tell this first before I address all your questions. Now, before I address everybody, see, whoever is feeling like you are worried, you are sick, you are mentally disturbed, let me tell you, this is a phase, and this phase will pass. This phase will definitely. There are multiple people with multiple scenarios. For example, this is your last attempt. Give your best. There is nothing to change, nothing to discuss, nothing to worry. If this is your last attempt, forget anything that is happening. Focus what you need to do. Hope for the best. After the attempt, think of alternatives, especially if this is your first attempt. Yeah, sorry, last attempt. Yes. If this is your last, at the end of the day, it is our life, and no one is going to save us. We can save ourselves when we get the job just studying without distracting. Absolutely, Akash. That is what I wanted to convey. No one is going to take care of you. It is us, it is the aspirant who has to work for himself. Aspirant has to accommodate for the change, and aspirant has to work. Nobody will come and stand. I am not talking about this, I am not stating this after the nuisance that is going on. No, I have been telling this since day one. Any tutor, any guide can do only 10%. Rest 90% it has to be done by us. Now the scenario is very bad, I know, but the bad scenario is for everyone. And the other thing is, please keep in mind, there might not be a lot of improvement, might not be a great improvement that is going to happen in CGL. There can be chaos. See, SSC said they are implementing multiple solutions and multiple technologies to come up with a proper answer. And I am from computer science background, and I know when you are implementing a software, you do a lot of beta testing. And when you are testing, unless you test it on a full scale, let us say you scaled up a project where your target audience are 1 lakh people, unless you test it on at least 5 lakh to 8 lakh candidates, you cannot expect the kind of problems that it is going to pop up. So the harsh reality is, SSC 2025 is going to be a testing ground for the new solution. So there will be problems, accept it. Problems are going to be there, and there might be a re-examination. Instead of 59,000 students, there might be a re-examination for 2 lakh students, or maybe 2.5 lakh students. But there could be problems. First thing, accept it. Okay, we will come back. Just a minute. So please accept the issues, and please accept the issues. Stay focused as you are studying. Please continue with the studies. And as someone else suggested, we will come back to the topic. And yeah, once the class is done, we will do it. Break is done. Enough of break now. Till now, we looked at very conceptual part. We spoke about what is orbit and what is orbital velocity. Now we know that satellites are bodies that rotate around the Earth's surface. They rotate around the Earth's surface, and we have to throw them with a particular velocity. The velocity with which we are throwing our satellites out of the atmosphere or to the end point is called as orbital velocity. So the satellite lifts off, the rocket lifts off. At each stage, there is a force that is given, and in the final stage, there is a propulsion, and after the propulsion, the rocket that lifted off at 90 degrees will take, at a perpendicular to the surface of the Earth, will take a 90-degree turn, and it will start rotating around the Earth. Now, the movement, the path is called as orbit. We saw low Earth orbit, middle Earth orbit, and high Earth orbit. We know that all these orbits are dependent upon the height. No, we should not throw them with escape velocity. Our velocity should be slightly lower than escape velocity. If you throw it at escape velocity, it will escape the Earth's gravity and you cannot have it working. So, we know that there are low Earth, middle Earth, and high Earth, and all are based on heights. This is about the basics of orbits. Now, in the second part, we need to look at some of the most famous space missions. This is a factual. This is factual. I gave a list. These are famous. They can ask you match the following. For example, Sputnik, USSR. Vostok, USSR. Which is the first mission that carried a human to the space? Vostok. Yuri Gagarin. Next, first manned moon landing mission, Apollo. Neil Armstrong and Buzz Aldrin. These are factual portions. They can ask you match the following type of questions, etc. From this slide, you need to make a notes out of this. Sputnik, first artificial satellite by USSR. Vostok, Yuri Gagarin is carried. It's a human space mission. Then Apollo, USS moon landing mission. Then USSR did a first spacecraft to land on Mars in 1971. When I'm talking about Mars, landing on Mars is very difficult. The reason is, one, Mars has a very, very thin atmosphere. Unlike Earth's atmosphere, Mars has a very thin atmosphere. Usually, what happens is when a body wants to land, let's say a body is there, a satellite is there, it wants to do a landing on a particular surface. What happens is, this is the Earth, you will start rotating around it, and you will keep reducing the size. For example, let's say this is the Earth surface, this is the Earth, and we want to launch a, or we want to do a landing. What happens is our satellite will keep rotating like this. Slowly, 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 steadily it rotates, and finally it comes and it lands. This is how we usually land on any surface. Now the problem with Mars is you cannot land on Mars directly. Sorry, you cannot rotate like this around Mars and you cannot land. Mars has a very thin atmosphere. So landing on Martian atmosphere is difficult. So soft landing on Mars is a very great feat. India also did this. India did a Mars mission, but first Mars mission of the world is done by USSR in 1971. Next, there is one space shuttle by USA. Columbia is the first space shuttle. It's a reusable one. It goes and it comes back to the Earth's surface. Then we have Hubble Space Telescope. This is also important. Hubble Space Telescope is a very big space telescope that is there. It looks at the Earth, it takes a lot of pictures, and it sends back to the Earth's surface. So this is Hubble Space Telescope. Then there is International Space Station. So International Space Station is a collaboration of various countries and it is world's property. International Space Station is placed in the low Earth orbit. It constantly functions, it constantly does a lot of research and development. It does lot of it's a laboratory where a lot of work is going on. Then there is a spaceship one, there is Curiosity rover. Curiosity rover belongs to USA. This can be a potential question. This is a rover that landed on Mars. Rover is basically a robot. Don't worry, I have all those images and I'll tell you. Rover is a robot with wheels. It travels on the surface of the Mars and it can pick up materials. It will conduct experiments about the materials and it will send back the information. Such a rover is called as Curiosity rover. It is sending a lot of data, and these are various important missions that happened in the world till now. These are important. They will ask you in the exam in the form of match the following, where they can ask you mission and the country and all those kind of questions. Now, Hubble Space Telescope. Hubble Space Telescope. Now, in the next 10 minutes, I'll take up some very famous missions and I'll explain you what they do. First mission that I'm taking up is Hubble Space Telescope. Hubble Space Telescope can be asked in the upcoming exams because it is 35th year of launching Hubble Space Telescope. It was launched in 1990. This is a combination of NASA and European Space Agency. This is Hubble Space Telescope. So basically, Hubble Space Telescope is a very, very big telescope that is constantly looking at the Earth's surface. It is used to take up a lot of pictures. You can take pictures of the entire solar system, the solar system, universe, various stars, Earth's surface. So you can also take the images of different galaxies. It is basically, it's like a binoculars. It is our binoculars. It is a very, very big binoculars with around 6.5 meter long diameter. The aperture is around 6.5 meters approximately. I don't remember the exact numbers, but it is around 6.5 meters and it is basically a monocle. Through the monocle, we can watch the entire Earth, we can watch universe, we can watch satellites, galaxies, etc. etc. So this is your Hubble Space Telescope. And Hubble Space Telescope is used to look at various exoplanets, that is, far off planets that are there outside our solar system. This is Hubble Space Telescope. The upgraded version of the Hubble Space Telescope is known as James Webb Telescope. So it is also again a monocle. Sorry, the 6.5-meter length diameter belongs to JWS. So these are all telescopes. I hope you saw some telescope when you were in your childhood. So these are the space telescopes. The second telescope is James Webb Telescope. This is a project of NASA, Europe, and Canada together. The difference between Hubble and James is James can do infrared imaging. James has spectral imaging, and you have infrared cameras. So that is one difference. So you can look farther. You can look at infrared spectrum. You will have better images that are available. Next, this is future project. Nancy Grace Roman Space Telescope. This is again a future project. The expected aperture is around 12 meters, and it is around 100 times wider than Hubble. It's a very, very big monocle. Nancy Grace Roman Space Telescope. It is a project of NASA, expected to be launched in 2027. So they can ask you a question on this either in 26, 25, or even in 2026 exams also. Right? So these are about the telescopes. There are three telescopes that I spoke. One is Hubble, second is James, future one is Nancy. Now we will look at various Mars missions. As I was telling you, exploration of Mars is difficult because Mars has a very, very thin atmosphere. So you cannot directly, I mean, you cannot orbit around Mars. If you have to land, you have to do a hard landing. You have to directly come and land on the surface. So many of the times, Mars landing fails because doing landing is easy, but you will do hard landing. You will fall on the surface, then your payload will not come out. You cannot do any further explorations. So soft landing is extremely important, and one such rover that went on Mars is Curiosity rover. This is your Curiosity rover. Curiosity rover is USA's Mars rover. The goal is to understand whether Mars supported life anytime or not. Next, US did one more mission, that is Maven. Maven mission, the aim is to study the Mars climate, Mars history of the atmosphere. What kind of climate history was there? That is studied in Maven. Whereas Curiosity rover landed on Mars, the aim is to study the Mars surface. Next, Mangalyaan. The main goal of Mangalyaan 1 is to study the atmosphere surface imaging. As you see properly, first you have to look at the surface. You have to understand how surface is there. You have to understand how atmosphere is there. And in second stage, you will do landing. In the first stage, you cannot do landing. Yes, Mars 3 was also successful. Curiosity rover belongs to USA, and this can be asked in your exam. Mars 3 is the first one. So Mangalyaan, it was launched in 2014. India is the first Asian nation to get into Mars. So to get into Mars atmosphere, you need slingshots. First, you need to get out of the Earth atmosphere. From there, you have to do orbit. You have to keep moving. Once you start moving, then you will do another sling movement, and then you will get into Mars orbit. It is very, very difficult. So India achieved this in 2014, and India is the first Asian nation to achieve this. Now you might ask me, why do we do all these things? Why do we develop all these things? Why do we need these kind of technologies? Do we really need to look at Mars? The point is, all these technologies have a lot of practical applications. For example, our current day missile systems, our current day ballistic missiles, cruise missiles, various avionics technologies, a lot of things that are there are a byproducts of various space missions. This is about Mangalyaan 1. Then in 2016, there is one more mission, that is ExoMars. ExoMars belongs to Europe and Russia. The goal is again to study methane gas. USA did one more landing project, that is InSight Lander. InSight Lander belongs to USA. This is InSight Lander. They landed on Mars surface, and there the objective is to study about the Mars earthquakes. When there's an earthquake is on Mars, their objective is to study and understand the seismic waves. You might have studied in geography, seismic waves are a very good source to understand the interior of the Earth. Similarly, to understand the interior of Mars, they sent InSight Lander. Then India is planning another Mars mission, that is Mangalyaan 2. That is our upcoming Mars mission. Along with that, in 2020, there are three new major missions that happened. One is Hope Orbiter, it belongs to UAE. The Mars missions of 2020, Hope Orbiter belong to UAE. China, it is Tianwen. Then the USA also sent one more thing, that is known as Perseverance rover. Now, along with that, There is one drone that was sent by NASA. In 2020, NASA sent one drone which is known as Ingenuity drone. The drone has the capability to lift off again. Rover falls, drone is released, drone is lifted off, and drone can conduct a lot of experiments. So these are the questions that they can ask you. In these slides, what you have to study is very simple. You have to study what is curiosity, what is the rover or the project and the country. For example, Curiosity, USA, Maven, USA, Mangalyaan, India. Then ExoMars, Europe and Russia, Insights Lander, USA, Mangalyaan again, India. Then you have to study about Hope Orbiter of UAE, Tianwen, China, Perseverance of USA. These are the kind of questions that they will ask you, right? And this is about the upcoming Mangalyaan 2. Mangalyaan 2, India's plan is that we will send a lander. A lander will land on the Mars surface, and we will throw a drone as well. So these are our plans in Mangalyaan 2, where ISRO wants to prepare and operate a helicopter along with a rover on the Earth's surface. And if we successfully do this, then India, this is our first attempt to touch down on a different planet. I hope Mangalyaan 2 is going to be extremely successful. So these are about Mars missions. Then these are the list of missions, important missions that happened from 2015. These are in current affairs. For example, NASA's New Horizon, to fly by Pluto. You study this, these are factual. I'll show you what to study. 2015, NASA flyby around Pluto. Then Japanese space agency name is JAXA. USA, NASA. Russia, Roscosmos. And Japan, it is JAXA. Europe, it is European Space Agency. So JAXA's mission is Hayabusa 2. Then you also have NASA's Cassini mission to go to Saturn. China, CNSA is China's space agency, Chinese National Space Agency. India has ISRO, USA has NASA, right? Europe has European Space Agency, Russia has Roscosmos. They can ask this question also. Again, NASA has InSight. NASA also launched NASA's Parker Solar Probe. So these are various missions that are important. You have to look at these missions. They can ask you in the exam. In 2023, Chandrayaan 3, ISRO's landing on moon. I'll talk about Chandrayaan, don't worry. Then India did Aditya L1. There are n number of questions on Aditya L1 in steno. So Aditya L1 is important. Luna 25, Russia's moon-based mission. These are current affairs with respect to different missions that are happening around the world. So are there any questions with respect to Mars? If Mars is completed, then I'll come to moon. We will take up moon missions and we will complete today's class with moon's missions, and I'll help you understand what are moon missions. In the next class, I'll take up the other missions. For the next 10 to 15 minutes, we will talk about moons. Yeah. Please come up with questions that you have on moon. Yeah, we'll have a defense class separately. We'll have a defense missiles and defense class separately. So are there any questions with respect to Mars? No questions? Good. Clear. Chandru is like communication based for Mars. No. Moon is different. No, it is not a communication base at all. Moon is not a communication base at all. You want me to show the all the slides are available in Telegram. Don't write it. Don't write. All these slides are available on Telegram, and the link is already pinned in the comments. And along with that, after the class, we have posted a free quiz for the class. The link of the test is there in the description of the video. Once the class is completed, you can take up the test. That test is created using the questions that were asked in steno exam. So you can take up the test. Now let us come back to various missions of the moon. Mars is done. Moon. Moon, we know it is closer to the Earth's surface, and there are a lot of attempts to go to moon and to do lot of missions, right? So moon missions, they can ask you moon missions in the exam, where they will give you a moon mission and they will ask you which country did this. USA did 4 moon missions. One is Ranger program, second is Surveyor program, Apollo program, and latest one is Artemis. In Apollo program, USA sent first human on moon, that is Neil Armstrong and Buzz Aldrin. So US has 4 programs. One is Ranger, second is Surveyor, 3 is Apollo, 4 is Artemis. All these programs are USA's programs. USSR has a moon program called Lunar program. China's program is Chang'e. Japan has three programs. One is Hithane, Selene, and Slim. Don't write this. Slides are available as I told you, but you need to know what to study from this. Now we will talk about the most interesting aspect, that is Chandrayaan, India's moon missions. India conducted multiple moon missions. We have Chandrayaan 1, Chandrayaan 2, and Chandrayaan 3. We will understand how we go to moon, what we do there, what are these Chandrayaan missions. Now, to understand or to go to any extra celestial body, the first step is to orbit around the body. Directly, you cannot go and land anywhere. So the first step is to go orbit around it. Second step is to land on it. When you are orbiting around the body, you will understand the atmosphere, you will understand the difficulties that are there, you will understand the path and the velocity that is needed, and that is when you will go and land on it. So India did three moon missions. All the three moon missions are named as Chandrayaan. Chandrayaan 1, Chandrayaan 2, Chandrayaan 3. The first mission, Chandrayaan 1, is a orbiter mission. That is, a satellite went from Earth, it orbited, moved around the moon. You cannot here. See, the point is, to directly land, you need a lot of data, you need a lot of understanding. Unless we send our own satellite, nobody is going to give us the data. Nobody is going to help you with the technologies that are needed to do projects of this kind. That is one of the reasons why India's space program took a lot of time to take off. So the first mission of India around the moon is moon's orbiter mission. We orbited around the moon at around 100 kilometers. Now, I am going to talk about various payloads that are there from here. The class is going to be slightly technical. The reason why I am talking about payloads is, if you look at this question, which of the following statements are true about Aditya L1 mission and the payloads? What are the future impacts of Aditya L1 mission? These are two questions that are seen in steno. See the questions. It is not Aditya L1 belongs to what thing. Is it about going around the sun, or is it India's or not? No. It is about what is the payloads. What is the future impact? So I am going to take the class into slightly technical direction. It might be complicated at the outset, but these are important. They are asking you questions on this. Now we will look at Moon's mission. Before that, I have a question. Instead of mentioning Buzz Aldrin, sometimes it will be mentioned as Edward Eugen. Okay. So please don't think that I'm wasting your time talking about various payloads and I am talking too technical. They are asking you questions on it. Now, first mission is Moon's orbiter mission Chandrayaan 1. It orbited at around 100 kilometers. The original objective is to map the entire surface of the moon. Now, there was one question from you who asked, what happens if I land directly? If you want to land directly, or if you want to land, for example, you need to know the surface. Where are mountains? Where are craters? Where is a volcano? Where is a depression? You need to understand all these things, and this mapping is called as geological mapping. This mapping is done using various photographs. So in the first step, the orbiter will go around the moon multiple times and it will take a lot of photographs. It will help us understand where are craters, where are mountains, where are depressions, where are volcanoes. We will look at all these things and we do this kind of mapping, and this mapping is called as geological mapping. We do all of that. For that, we need various instruments. All these instruments are called as payloads. Any satellite has lot of technical instruments. Technical instruments are fixed to the satellite so that they will do whatever work they have to. Such instruments are called as payloads. Any satellite has payloads, and moon's atmosphere is not even there. So those technical instruments are called as payloads. Now let us look at some names of the payloads. In today's class, I will introduce you to only 5 payloads and 5 names so that it will be easy for you to understand. On Chandrayaan 1, there are 5 different instruments that are placed, 5 payloads. One is a camera called as terrain mapping camera. Terrain mapping camera, the objective is you go around the surface, you understand the heights. Terrain mapping, topography mapping, cartography is all about drawing maps. There you are understanding the heights, you are looking at various heights that are there, and that mapping, that is called as terrain mapping camera used for topography mapping. Next is you have a spectral imager. The meaning of spectral imager is the spectroscopy. At the basic terminology, spectroscopy is like a scanning. It is like a scanning. We scan the elements, and through spectroscopy we can understand the composition of anything. For example, if I am doing a spectroscopy for this pen, I can tell you what minerals are there in this pen, what material is there in this pen. Is this made of plastic? For example, what is the amount of carbon in it? Is there hydrogen? Is there nitrogen? Through spectroscopy, I can tell you the composition. So the other payload that is there is known as a high spectral imager. It will do spectral scan. It will scan the surface of the moon, and it will help us understand what kind of minerals are there. Then we have lunar is moon, laser ranging instrument. The meaning of laser ranging instrument is, as I was telling you, in the first mission our objective is to understand the topography. Understanding topography, the meaning is we are understanding the height. For example, on this surface, at this point I have 5000 meters elevation. At this point I have 2000-meter depression. At this point I have 3000-meter elevation. To do this, there is one more payload which uses a laser. You send a laser, just like a sonar, where you are using a sonar to understand the bottom of the ocean. Similarly, you send a laser, you will understand the height. So such instrument is called as lunar laser ranging instrument. Then you were asking what happens if I land. There in the first mission we sent a body called as moon impact probe. It is attached to the satellite, and after a point of time this probe will land on moon. Once it lands on moon, we will understand with what force are we landing. What is a vibration? Did the lander break? Did it break into multiple pieces, or what happened to it? This is called as moon impact probe, where you are understanding the impact of landing. And finally, there is a radar, a synthetic aperture radar. The radar purpose is to understand or to take various images, irrespective of whether there is a hailstorm or whatever weather it is there. You are taking a lot of images. So this is the whole purpose of Chandrayaan 1. The purpose is to understand the moon's surface, to map the surface, to understand what happens when you crash land, when you land something, and what are the minerals that are there, etc. etc. This is Chandrayaan 1. Chandrayaan 1 is very, very successful. Right? Chandrayaan 1 has been very successful, and we conducted Chandrayaan 2. Now look at this question. I am not sure you will answer this question today because we will hand it tomorrow. But I want you to look at this question. Consider the following statements below regarding Aditya L1 mission and its payloads. The suit payload on L1 is designed to image solar disk in near UV spectrum, study the temperature, chemical composition. The SOLEX instrument is an X-ray spectrometer to study solar phase and the X-ray wavelengths. See the depth at which they are asking question in the exam. Now, if there is a question on Chandrayaan 1, what is the utility of moon impact payload or moon impact probe? There is a statement, the moon impact probe MIT is piggybacked on the satellite to understand what happens when satellite is landed on the surface of the moon. Can you handle the question? I hope you can handle the question. So this is the reason why I wanted that is the reason why I started taking the topic into technical manner. We will do in technical detail about Chandrayaan 3, about Aditya L1 mission and other missions of ISRO in the next class. Yes. So this is about Chandrayaan 1. So once we understood Chandrayaan 1, Chandrayaan 2 went with certain specific objectives. Chandrayaan 2, our objective is to land on the moon. We wanted to land on the moon. We want to detect whether water is there or not. So we wanted to land on the moon. We wanted to move on the moon. We wanted to understand the surface of the moon. We wanted to study what minerals are there and what is the exosphere, etc. etc. With these objectives, Chandrayaan 2 was designed. So Chandrayaan 2 had an orbiter. Now you tell me, what is the purpose of orbiter? This is Chandrayaan 2 basically. What is the purpose of the orbiter? You tell me now, what is the purpose of lunar orbiter in Chandrayaan 2? What is the purpose of lunar orbiter? to study the atmosphere, to take images, to take photographs, right? So Chandrayaan 2 had a lunar orbiter. No, there is no landing in Chandrayaan 1. It was a hard landing. It was just to understand the impact. That's it. Chandrayaan 1 is not landing. Chandrayaan 2 had one lunar orbiter to go around the moon again. Two, there is a Vikram lunar lander. Chandrayaan 2 objective is to land and to move. The lander is called as Vikram lander. This is the lander. You see here, this is the lander. This is the basic module. This is whole payload. The image is the complete payload. And in payload, we have a lander. We have a lander. The lander name is Vikram lander. Then we have a rover. Rover is the name of the rover is Pragyan rover. The rover objective is to move. You landed on a place. Now you are releasing a robot. Robot is moving. It is collecting various samples on the land and it is trying to understand what is the composition of the land. The objective to understand the mineral composition, to detect if there is water or not. You have to move along the surface, right? So the mover is called as rover. The name of the rover is Pragyan rover. Lander is Vikram lunar lander. We could not land successfully in Chandrayaan 2. I will explain you why in the next 2 minutes. But the point is, we did not land properly. It was a crash landing. So Vikram lunar lander crashed on moon's surface and we could not deploy our rover. So Chandrayaan 2 is not successful. But I will tell you why it is not successful, what is our aim and objective. To tell that, I want you to understand every celestial body, for example, has poles, North Pole and South Pole. What is that robot? Which robot there? Okay, you have North Pole and South Pole. Now you have, we have equator, we have North Pole, you have South Pole. Earlier, all the missions that were sent, that the landing that was done on the moon completely is around the equator. Apollo, Ranger, Surveyor, Apollo mission, Luna mission, US, America, China, everybody landed around the equatorial region, whereas India attempted to land on the South Pole. Landing on the South Pole of moon is extremely difficult because one, it is pitch dark. The equatorial region of moon is exposed to sunlight, there is visibility. Whereas one, South Pole is pitch dark. Two, South Pole landing is also difficult because there is lot of mountains, there are a lot of craters on the South Pole, there is no much of even surface. So landing on South Pole is extremely difficult. Because of that, India could not land successfully on South Pole. Chandrayaan 2, the mission objective is to soft land near the South Pole region, rove, conduct local experiments, etc. Right? So this is about Chandrayaan 3. India was successful in Chandrayaan 3 in 2023. And India is the 4th country in the world to do a soft landing on the moon and first country in the world to land on South Pole. In the next 2 minutes, I will tell you why South Pole landing is important as well. So India in Chandrayaan 3 mission successfully landed on the South Pole of the moon. We demonstrated that we have the technical capability to land on the South Pole. We can move on the South Pole and we can conduct the in situ, that is local experimentation. So Chandrayaan 3 did a successful touchdown. We touched down on the South Pole region of the moon and India is the first country in the world to do this. Now the question is, why is South Pole landing so important? This is a World Economic Forum article that was written in 2023, which says why landing on South Pole is important. It is important because out of the entire surface of the moon, scientists are expecting that water is there at the South Pole. So because of the ancient water, we want to study whether moon's surface can support any life. What about the water that is there? With that, we want to understand the history, the climatological history. And if we are successful and we can say that there is water on the South Pole and this water is useful, then we can use that water in future missions where we can cool down our equipments. We can work on moon for a longer period of time. The reason why cooling is important is because when your satellite is coming onto the moon surface, it overcomes a lot of friction. So when it is overcoming a lot of friction, obviously it gets heated up a lot. So you need water. If there is water on moon, we can utilize it. We can utilize it for cooling. We can utilize it for producing fuel, oxygen, etc. So because of that, South Pole exploration is extremely important, and India is the first country in the world to successfully soft land on South Pole. Now, Chandrayaan 1 had a lander. This is a propulsion module. Propulsion module is the module that gives the final thrust or the energy to get into the orbit. We had a lander and we have a rover. Right? So this is all about Chandrayaan 3 and Chandrayaan 3 payloads. Number one, the main payload that is there in propulsion module is spectropolarimetry of habitable planet Earth payload, that is SHAPE payload. They will ask you as SHAPE payload, they will not worry you about the full form. So shape payload is to understand, to analyze the light that is there. To understand the light that is there, that is spectropolarimetry, that is one payload. The other is about lander. Lander has thermophysical experiments, etc., etc. Today I will not bother you about these technical payloads. In the next class I will take up the technicalities of Chandrayaan 3. So this is for today. In this class, in the next class, we have to talk about International Space Station, Bharati Antariksha Station, and solar missions, etc. There are a lot of interesting aspects that we still have to talk, right? So this is about Chandrayaan 3. And yeah, this is for today's class. There is a question from middle class boy. Pro steno general awareness topic wise videos, please. This is what is about steno, right? Earlier we never studied space for an exam. This is based on steno. See, I want to tell you one thing. If somebody is teaching you questions, if somebody is making you do questions, that is useless. You have to study the topic, you have to understand the topic and the concept, and you should do the questions by yourself. So I am not taking up much of the questions. Yes, I will take up questions where you are already good at the topic. For example, Indian national movement. We will take up questions. We will do based on questions. But for these topics, what is the use if I just simply take up the 12 space-based questions that were asked? For example, I'll show you the questions. I think I have those questions with me at this moment. Yep, I have the questions. See, these are your questions. Now, if you want me to take up the questions and I want to do, I'll tell you that this is Aditya L1, this is the payload ho gaya. We can do this, but there is no use of this. So, questions, you do this by yourself. I will teach you the topic that is needed for the new topics. This is about today's class. Are there any questions or can we end this for today? Your feedback, please. And Siddhi will continue live sessions. We will have one live class every day from 6:30 to 7:30. We will continue with the topics and this will be an ongoing process. We will have courses. We will have beginner based courses, etc., etc. But every day we will have one free live session where we are taking up new topics. No queries. Thank you. And there can be a question on black hole. Yeah, it's been really long that I took up a session, but we will continue sessions. On YouTube, we will take up sessions of GS and English. Tarak, once you read this, you revise, you will understand, Tarak. You have to read this a couple of times. You do you want to start for 2025, Harshit? As in, what is the suggested timing? No, you're not 7 to 8. It is very difficult. I have to go at 8 o'clock. I have to go at by 8:30. Okay, I go for a martial art practice session usually. I have to go there by 8:30. I'll take up a live class of parasymbols. All the classes will be live. No, there is no change in the MTS 50-day prep. We will post you the lectures also. We will, sorry, we not lectures. I'm extremely sorry. We will post you the sectional mocks and all. We will post them. There is no change in the plan. Thank you so much. Thank you so much. So this is today's class. Tomorrow we will take up monetary policy. Digest the entire space module today. Day after tomorrow we will do the next part of the space class. Tomorrow we are doing monetary policy, money, banking and reforms. So the live time is fixed from 6:30 to 7:45. I will not change it. We might need 2 classes. We might need 3 classes for a topic. It's okay. I don't have a problem. We will take up all the new topics. See, our plan is on YouTube. We will be taking up new topics and difficult topics. And in the courses, in the app, we will do from foundation. CGL 2025, we cannot expect a date exactly. Okay, we can't expect a fixed date. There are some sections of people who are saying that exam will be from 10th of September, but there are the other guys who are saying that SSC is facing a lot of problems, so they may not take it up in 10th of September. So it is clueless. Kedar, I'll give you a schedule from Monday. Yes, I will teach committees. Yes, I will take up committees. ACIO will be conducted on time. Okay, you want me to give a GS topic checklist? We will do it. No issues. I'll give that. Noted. One is GS checklist. One is GS checklist. Any other questions? That's it? No. Any other question is, see, if ACIO is clashing with SSC, go for ACIO. This time, expect problems. There will be problems in SSC exam. So if there is a date clash, go give ACIO exam. No doubt about it. My optional is geography. My optional is geography. I'm still here for the next 10 minutes. If you have any other questions with respect to any SSC exams, we are free to talk. Every day we will have a 10 to 15-minute interaction. I will talk to you in the last 15 minutes. So class is from 6:30 to 7:30, 7:40. Last 10 minutes is for interaction. We will have a talk, chit chat, etc. I am looking at the comment section and I'll take up all your questions. So you're free to address. Talk. How can you overcome? See, low marks are completely okay. May I know your name? Yeah, Sanjoba. Sanjoba, low marks are absolutely okay. This time, nobody is gonna get 130, 140s. If you're doing around 110, it's okay. And one more thing is, nobody is giving the exact new pattern marks. Everybody is doing some or the other tweaks, coming up with their own interpretation of new pattern. So it is totally okay. Don't worry at all in the first place. We will think of it, ma'am. Not right now. At this moment, I'm not taking up anything for UPSC teaching, but these classes are good. Can you repeat your question, Mallikarjuna, please? No. Once we complete everything in maths, then we will come up with maths separate course here. Give guess on CHSL. See, if you want me to guess, it could be from 10th of September. It could be from 10th of September. But again, if there are glitches, etc., we don't know. See, I'll tell you, there is a past experience that happened in 2017. I don't know how many of you are aware. In 2017, there was sci-fi, there was a paper leak, there was a lot of nonsense. So after that, SSC again did this kind of vendor change, etc. A lot of nonsense happened, but there they took a lot of time here. They took almost 5-6 months. But this time the new vendor is already there. The setup is already there. So you can expect exam somewhere in the mid of September. 10th to 15th of September. See, on mains and YouTube channel, the point is, one, I'm completely prepared for mains. Second thing is that I'm not like even if I clear mains, even if I get my name in the finalist, I'm gonna stay here. This is there. That's just one dream that is left out, and I want to see my name there. That's it. I mean, so this is my first priority. Yeah, we will rectify all the errors, Yasin. We will rectify all those errors. And do I have anyone from Northeast in the class? Sir, MTS 50-day plan, low English, daily, to-do list, idioms. Yeah, I'll give you. There are a couple of idioms. Now that steno papers are out, you can start using steno vocabulary as well. Do I have anyone from Northeast in the class? NAN? See, anyone who is there from Northeast, you can reach out to us on our WhatsApp. We want to offer a special discount for all those guys from Northeast. I worked in Northeast and I have a special attachment with Northeast, and I saw the places. I saw how remote Northeast is, and how these exams are very important for all those people who are from Northeast. So at Siddhi, for anyone who is from Northeast, if you reach out to us, we will give you special coupons, etc. Yes, I will say. No problem here. At max, they might cut some marks. No problem. That's just for my satisfaction here. This time, UPSC is only for satisfaction. I don't care if I clear it or not. Okay, this is my second innings. From Manipur TNT. Yeah, please reach out to us on our WhatsApp number. I'll give you our WhatsApp number. It is just a second. And for any queries with respect to courses, etc., you can always reach out on our WhatsApp. Kindly don't call. We are looking at disabling all the incoming call options on that number. But nevertheless, this is our WhatsApp number of Siddhi. Yeah, we want to give this almost at 50% cost for anyone who is from Northeast. We need daily. We will do that, Yasin. We will slowly do it. ACIO 24 was very different. Can you suggest practice? CAPF papers and serious papers are very good if you want to practice those kind of questions, Chetan. Hi, Chetan. How are you, by the way? It's been really long. I saw you on the channel. How are you? You can practice serious and CAPF questions. So, yeah, this is all for today. See you all again tomorrow on economic reforms. And day after tomorrow, we will take up space tech and we will continue. We will have a blend of English and GS together. Something in GS section in mock tests, yes, they are relevant. And sometimes in GS section, mock tests, one statement is known and the other is not known. You're sitting in the fence whether to guess. See, you can guess based on 50-50. And I will do newspaper sessions. You can get serious vocab compilation. One compilation we posted on our Telegram, the other we will do slowly. See, I don't want to see you complete you clear your exam. You come to Siddhi's office. I'll definitely share my stories. I'll share my stories once you reach Siddhi's office. Beyond that, I don't want to talk anything on this channel. One thing I can tell is that even if I clear the exam, I'm in no mood to get back into government. When that phase is over. 3 to 4 days. Yeah. 2026, 3 to 4 days we will start talking. If not CGL, at least yes, CHSL will happen properly, hopefully. I haven't started general awareness. See, if you have not started general awareness at all at this moment, don't touch it. Yes, I can give you UPSC guidance. Please reach out on the WhatsApp number that is there on the screen. I will give you guidance for UPSC. I don't have a problem. I don't have a problem at all to guide you for UPSC. We will start slowly talking about CDS, CAPF and other exams on this channel as well. 1 week, Santosh. In the next week, I'll give you the 2026 strategy. Right? So, this is all for today. Thank you so much for staying in the class. And yeah, all the best. See you all tomorrow on economics, economic reforms, money, banking, committees, etc. etc. I'll tell you the whole story, context, how banking in India has evolved, and what are the problems, right? So that's it. Satya, there is nothing great in this. I'm working hard for my better future. That's it. If I work hard at this point and I do whatever is needed, I can have a comfortable future. So I'm working for my future in my second innings. That's it. There is nothing great and all here. You are working for your career, your future. I'm working hard for my future. That's it. Right. So please, for those friends who are from Northeast, please reach out on our WhatsApp number. We want to give you our courses at 50% of whatever is slated, so that it can help you in your preparation. Yes, every class is live. 50% will be provided for all those from Northeast, and we just want to confirm that, and that's it. So this is all for today. Economy is a live class. All classes of Siddhi on YouTube will be live. Till now we posted a lot of recorded videos, but yes, we found a way to manage everything. Every live class is fixed. It is from 6:30 p.m. There is only one live class that will happen on Siddhi every day. Class timings are fixed, 6:30 to 7:30 p.m. Right? So see you all again tomorrow. Till then, bye bye. Good night. Bye.